Okay, so here is the answer to problem number 2. So first let's take a look at what we've got. So we are making decisions, right? We have exterior colors, interior colors, and 3 interior styles. Also, transmission can be either manual or automatic. An engine can either have 4 or 6 cylinders. It's not 4, it's 4 cylinders is like one choice. 6 cylinders is another one. So altogether, we're making 5 different choices. 1, 2, 3, 4, 5. And the first choice is, there's 7 options for the first choice, 3 for the next choice, 3 for the next one, 2 manual automatic for the next one, and 4 or 6 for the last one. So these are our choices. We multiply them. You guys seem pretty good with that one. Great. The next question is, 3 door prizes are awarded at a party. First person gets a trip to Vegas. Next one, dinner for 2. Third one gets a $10 gift card. Does order matter? Does order matter, you guys? Does it matter whether you get a trip to Vegas or whether you get a $10 gift card?
Yes.
Totally matters. Absolutely. So order does matter. So it's a permutation. How many people am I picking? Let's see, I have 112 people. I'm sorry, 112 people, and I'm picking 3 of them. Order matters, so I'm making 3 choices. How many options for the first choice? 112. Now, once you get drawn, you cannot get drawn again. So how many options for the second choice? 111. And the third choice? 110. Good. And you're going to multiply these together. That's it. All good. I think someone had the answer. This looks like the answer there. For your exam, you do not, I need to see this. You need to show me your work. You need to show me what times what times what. You can't just give me the answer. I don't need this, but I do need this. This is the key part right here. That's where you get your points. You have to prove to me you understand where it comes from and what numbers to multiply. All right. Now, wrong one. Now we're going to talk about if order doesn't matter. So, this is a bit prettier. You can take a look at that too if you want. All right. What if order doesn't matter? Is it better if it's bigger? Is bigger better? Let me try to do that. Maybe that's better. Okay. So, let's get a reader for this one. How about Sharia? Can you go to read for us? I don't know where it is. Ulysses, go and read for us. That's fine. Here somewhere. Will?
What if order doesn't matter? You want to pick 3 chaperones for a field trip. The choices are Alex, Ross, Laura, and Rigo. How many ways can you pick 3? Does order matter?
Right.
4 ways.
So does order matter? Guys, what do you think? Does order matter?
No.
No.
No, there's chaperones. Great. Keep going.
4 ways. Think of it as not Alex, not Ross, etc. What if order mattered?
Right? Thank you. That's perfect. Thank you. So if order mattered, then it would be 4 picking 3, right? So how would I do that one? I would say, okay, I'm picking 3. So I'm going to have 3 spots. And I've got how many options for the first spot? There's 4, next spot, 3, next spot, 2. Okay, so this would be 24. So if order mattered, there'd be 24. Good? But we're in a spot where order doesn't matter. So for us, whoops, mouse. Okay. We'd have 24. Okay. And say I picked Alex, Rigo, and Ross. Right, just randomly I picked those three. Order matters. Say the first guy is going to be telling the kids, checking the kids and making sure they all get on the bus. The next person is going to be gathering up all the lunches, all their lunches. And the third person is going to be making sure the bus driver knows where to go and giving directions to the bus driver. How many ways can I put these three guys in order to arrange it so that one, give them each a different task? So the first one is, again, like checking out the kids. Second one's getting the lunches. Third one's giving directions. How many options for the first spot? How many options do I have for who picks the kids, who checks off the kids? 3, thank you. How many options do I have for who picks grabs the lunches? 2. How many options are there for, well, whoever's left, there's only one spot left. So this is 3 times 2 times 1, 6. What was that again with factorials? Do you guys remember? 3 times 2 times 1 is 3 factorial. 3 factorial is the number of ways of arranging 3 items. Just a quick reminder, we did that earlier. So now, here's my question. If order matters, it's this permutation, 4 times 3 times 2, 24. These are all 24 possibilities. How do I get from 24 to 4? Because if order doesn't matter, it's only 4. So order matters, 24. Order doesn't matter, 4. How do I get from one to the other? I divide by 6. Why am I dividing by 6? So take 15 seconds, 30 seconds maybe, see if you can figure out why do I divide by 6? Why not divide by some other number? So think about that. Try to figure it out. Color matters, by the way. I'll give you a hint. Color matters. Okay, anybody have an idea? Anybody have an idea? Don't leave me hanging here, guys. Really?
6 that are of each color.
Yes, there are definitely 6 of each color. That's definitely true. Someone's going to say something else. Why does that matter?
Because those are all just different arrangements of the same 3.
Yeah. So each of these colors is a different arrangement of the same group. So in other words, this purple group is Ross, Laura, and Alex, and just different ways of arranging Ross, Laura, and Alex. They don't actually mean it's a different choice. If I'm picking Laura and Alex and Ross, and I don't care what order they're in, these are all just the same way. First, 1, 2, 3, 4. There's only 4 different ways. Do you guys see what I'm saying? So if I should just erase those. Those are actually confusing, I think. If Ross, Alex, and Rigo are all the same, all these different arrangements only count as once, then this was really only one item. And this is only one item, and this is only one item, and this is only one item. So altogether I only have 4 items, 4 possible ways. So I divide by the number of ways of arranging Laura, Alex, and Ross, which is 6 ways. That's why I call dividing out the duplicates, because these are all duplicates. Right? If order doesn't matter, if order matters, they're all different. But if order doesn't matter, they're all duplicates. How many duplicates are there? It's however many items you have, factorial. How many ways there are of arranging that many items. So this would be r factorial, because I'm arranging 3 items. In this case, 3 factorial. So here is a shortcut for your combinations doesn't matter. If order doesn't matter, you take your permutations, NPR, and divide by r factorial. That's it. That's what I would say here for your combinations. NCR is NPR divided by r factorial. So here I'd put NP PR, I can't draw very well with this, over R factorial. That's what I would say would be the answer for that, this part here. And what did you guys have up here? Someone tell me how did you guys write up here? I think I said, well, you can just do this. Start with n and multiply down r spots. That would be the simplified way of doing this one up here, right? If I want 4p3, I would start with 4 and multiply down 3 spots. 4 times 3 times 2. Done. Or like your lab problem was 112. Start with 112 and multiply down 3 spots. 112 times 111 times 110. Done. Okay, let's go back to here.
I don't have.
So here is another, this is kind of how I do it. You start with n and you multiply down r spots, right? And then NCR is just NPR over r factorial, just this right there. These are the formulas the book's going to give you. I think they're more confusing than they are helpful because they're not intuitive. They're just memorizing a formula. They aren't, they don't follow sort of a logical reasoning. All right, so let's take a look at this one. Flyer types. Let's do an example. Maybe that'll make things clearer. So here I have, let's get a reader. Tate, can you read for us? Actually, Gavin, go ahead and read for us, Gavin. Tate's having internet issues.
Flyer types. An advertising executive must select 3 different photographs for an advertising flyer. If she has 10 different photographs that can be used, how many ways can she select 3 of them?
Great, thank you. So let's assume that the order of the photographs doesn't matter. They just need to be in the flyer or not. No big deal. So order does not matter. So this is going to be 10 items, and I'm going to choose 3 of them, since order doesn't matter. And like I said before, that's going to be 10p3 over 3 factorial. So in other words, how many items am I selecting? I'm selecting 3. So I'm going to make 3 spots. 1, 2, 3. And what goes in the first spot? I have 10 things. So 10 in the first spot. And this countdown, 9 and 8. Permutations and combinations are when you cannot reuse items. Right, you can't reuse these same photographs. But because it's a combination, you have to divide out the duplicates. There are 3 items, so it's really straightforward. You just do 1 for each one. 3, 2, 1. Done. So there should be 1 that matches up for each one and none 1. 3 items, 3, 2, 1 for a piece of cake. So you'll end up with 720 over 6, which ends up being 120. Okay, you guys you have 2 problems to do next. You have problems, nope, not that one. Here they are. These 2. So lab problem 24 and 25, hop in your groups and do them. As soon as you're done, you can go. In about 4 minutes, I'll pull you in to go over them in case your group didn't get them. You're turning in page 17 tonight, so you'll need to upload page 17 and quiz 4.3. Those are the 2 pages you're uploading for today. So hop in your rooms, and again, as soon as you finish up lab 24 and 25, you can go ahead and just leave. Let me ask you something actually real quick before we go to make sure people are clear. Raffle tickets, first prize is 100, third prize is 30. Does order matter here? Yeah. 30 bucks is not the same as 100. But here, every prize is 80. So does it matter whether you get picked first or third? Order doesn't matter because you both get $80 either way. All right, so hop into your groups, and then, like I said, I'll pull you guys back in about 4 minutes in case your group didn't get it, so you can, I'll go over them so you can make sure you understand it before you go. But if you got it, once your group finishes, you can just leave. Totally fine. Have a great weekend.